So let's see here. Come on, focus, focus, focus. You can do it. So is it drawing the Venn diagram, Gabriel, in particular, or just J is 2x, right? So when you see this, I don't know if you remember linear inequalities. If you were with me in grade 11 applied linear inequalities, we had something like this. So this is just introducing the variable. Remember the implicit constraint, x comma y has to be greater than or equal to 0. Remember those? So it's the same kind of thing. You're introducing the variable. So the variable in question is j, right? And so this is going to determine what values enter the set. So watch what I'm going to do here. I'm going to call this set A, right? So anywhere between -3 and 6, and x is part of, this is calling it's part of the I set. Do you know what I stands for? Numbers. It's the integer set. Integers, I can write on this, you cannot. Look at how beat up this textbook is, right? It's all ripped up. So it's integers are your whole numbers. It could be negatives, right? Sorry, 2 and so forth. So it spans, right? That's what we're considering here. So we're going to go from -3 to 6. So if you insert -3 here, you have -6, correct? And then let's try -2. 2 times -2 is -4. And then -2, right? Are you following? Sorry, I'm going to do this up here. -3, right? All the way to 6, right? So these are the integers we're considering. So I'm plugging each one into x here. So if I plug in -3, I get -6 out of this expression. This is kind of like the rule that describes what's going to be in set A. So I'm almost like building it, I'm constructing it. Does that make sense? Monday morning, I don't know, right? -2 goes in there, you get -4. Then you plug in -1, you get -2. Then you plug in 0. 2 times 0 is a bigger 0. 1 goes in there, that's 2. 2 goes in there, that's 4. 3 goes into x, that's 6. 8, 10, and you get the picture. So now I have set A created. I'm going to do the same thing for set B. Thank goodness it's still integers. Now I'm considering from -4 to 5. So I got to expand this a little bit. -4 all the way to 5, and I'm just going to cut it there, right? So these are the numbers I'm going to consider to create my set. So 3 times -4, -12. 3 times -3, 3 times -2, 3 times -1. It's multiples of 3. Do you understand that, right? So 3, 6. I have to think to make sure I don't mess this up. There we go. So now you've created both sets. How many ways can you represent a set? You can actually, in words, write what's in there. This is sort of doing that. It's like, hey, what's going to be in J? Well, it's going to be multiples of 2, basically. What's going to be in set B? Well, it's going to be multiples of 3, basically. So that's what's happening here. They're kind of making you build it, and then you can write it in actual set notation. I'm going to do this as well, because it's very likely that you will use it. What's this stand for again? Number of elements in A, 2, 4, 6, 8, 10. Number of elements in B, it's supposed to be a lowercase, okay? 2, 4, 6, 8, 10. There's 10 in each set, okay? Now, draw a Venn diagram using these two sets. Before I draw my Venn diagram, I want to see, do they have things in common? All right? Things in common. Why? Because that's going to determine if I'm going to have disjoint sets, if they're going to be joined, or if they're going to be subsets, right? Is one circle going to be inside the other? So I'm checking here, and I see that they definitely have something in common there. Tell me if you see anything else in common, because The 6, yeah, there we go, thank you. Yeah, absolutely. Anything else? 6, yeah. Anything else? Okay, so I would suggest if you have sets written like that, I would do the circling part because then you know, okay, these they share. Not subsets, right? One isn't a subset of the other, right? Because there isn't, like if B would be a subset of A, then everything in B would have to be inside of A as well, every single one. But it's not the case, so case closed. So my Venn diagram will look like that. Put a box around it, and I'm going to call this set A, and this is going to be set B. And once they share, I will introduce right away. Right, so we've got 4 elements in there. And then I'm going to go to A here, and whatever isn't mentioned. Okay, and then I'm going to go to B, negative 12. I don't do commas, really. You can. Sure, why not? Negative 3, 3. It's kind of like floating elements, right? It's almost like elements in a bag, right? That you put in. So I'm just going to quickly count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Which makes sense because I go 10 plus 1, 2, 3, 4, 5, 6, right? Because you won't double count, so there's 16 in total. But this is the confusing part, right? If this is 10 and this is 10, right? It's like, oh, what's the universal? What's the universal set? Am I done my Venn diagram? Because if you think of the universal set, I guess that would be, I'm looking at my universal set. These are all the values that I've used to create my new one. Okay, these up here on in the textbook. I actually used 6 as well. That's part of your universal. I would have to peek here. Anybody look, Gabriel? Did you look at the answer key in the back or no? Or you didn't even? Let me just check. I actually need to know myself how they did the universal here. You mean you don't know? Well, I want to make sure. Right? It's being recorded. As soon as you record something, you know, right? That's when you get things wrong. 172, this is question 6. So they don't have a, okay, so they're assuming we have those 4 in the middle, and so they're assuming that that's your universal set, like those are all the numbers to draw from. So there are no outliers in this case, okay? I will be very specific as to what your universal set is. So if I give you all the universal numbers and set A and B are not using up the universal, you need to make sure you put the outliers on the outside, okay? Okay, so let's continue our journey here. This is where you learn how to read your graph, okay? So determine A unites B or A or B combined, right? The union of sets A and B. And so I will just do that. Is it asking? Yeah. A unites B. It's just going to be all of this combined here. And they're actually asking you for using the correct set notation. So it's not the number of elements, it's actually stating the elements, combining them. So it has to be arranged. So I'm going to go from the smallest, negative 12. I'm going to have 16 in total. Okay, 16 in total. Negative 12, negative 9, negative 6. Yeah, negative 6 here. What comes next? Negative 4. Got it. Help me out. Yeah, help me out because it's Monday. sorry, negative, okay, and 0, and then 2, 3, 4, 6, 8, 9. Oops, I'm out of here. 9, then 10, 12, and 15. Okay, you can't forget about them. So you're like, oh my goodness, how can I double check this? I'm just going to go 2, 4, 6, 8, 10, 12, 14, and believe it or not, there are 2 more in there, 16, right? So the Venn diagram shows me I have 16 elements, and I double check that this is also 16, and then you're safe. Okay, so that's the union of the two. And then the number of elements in A or B would be 16, right? That's what the union is. It would not be considering anything outside. Okay. The next is asking for the intersection. That one is easy peasy, right? The intersection of A and B is just in order, right? Negative 6, 0, 6, 12. And we're done. Okay. And the number of elements in there would be 4. We've got that. We're done. That question is answered. Good, Gabriel? And I'm sure there were others in here that learned from it, so thanks for asking. Anybody else? Any other question in particular? Nobody? So the lesson was okay on the video? You were able to access it? Yeah? Okay, right on. I'm going to just pick a random one before we move on. Do you notice that, and again, you cannot write in your textbook, okay? I'm making this very clear. They all had an outlier. I don't want to highlight because then I give it away next time already to the next class, right? So 4 people did not like either detective. So the sets would be Sherlock Holmes and Hercule. How do you pronounce that last name? It's like a French. Poirot. Poirot. Okay, Poirot. Okay, for next time. So they're your outliers, and then they tell you how much are in each set, right? How many are in each set? So that in that case, let me just quickly figure this out. Even if they don't ask you to draw a Venn diagram, do it. Just do it. Even if you need to do it on scrap paper, I would strongly encourage you to do it on the question right there. So you've got 25 people. That's your universal set. At a mystery convention, right? We all go to those. And so we've got Sherlock Holmes, and there's an assumption, and I'll tell you how you know that there's an overlap. Obviously, it's possible that folks might like either one. So you've got the universal set is 25 people. When you fill this in, guys, 16 people like Sherlock Holmes, put it outside the circle. And 11 like Poirot, right? Then you need to figure out how many liked only Sherlock Holmes, how many liked only Hercule Poirot, right? So they're asking you, what are they asking you for here? Only, the word only, I told you that many times in the lessons. They're asking for this here. It's almost like a Pac-Man, right? They're asking for just this or just this, okay? They're just asking for these cutouts here, not the overlap. Does that make sense? So this is gonna be your go-to, right? You're gonna want to just figure it out. Like, what goes in there? Don't do it. Figure out the middle piece. Focus on the middle piece. I'm gonna figure out how many go in here, and what do I call that using proper notation? S intersects H, right? The intersection of the two. That's what I'm gonna focus on. What am I gonna use to find it? What principle? Pi. There you go, Sean. There you go. And so I'm going to go like this. I know this is tough on a Monday morning. I know, guys. So the number of elements in both is number of elements in S plus number of elements in H plus, I'm going to call this X. Okay, that's the union that I'm after, right? I'm going to call this X. And so you figure out what is this number usually? Actually, I've not done my thing. This is four people do not like either one of them. Those are your outliers. So you go 25 minus 4. 25 minus 4 goes on this side. That's what the union is, because if you take the 4 away from the universal, you're left with this. Okay? Then you get how many like Sherlock? 16. How many like H? I'm just going to call it H. And that's your unknown there. Okay, that's your unknown. So 25 minus 4 is 21. 16 and 11. I'm just going to leave them like that for now because I like to show that step. Oh, I'm making a mistake, right? What's the mistake? Yeah, you see it? That'd be a good test question. Find the mistake that Mr. Dirksen made, right? This cannot be added because then you would double count. You have to subtract. I noticed it right away on my third line. It only took me 3 lines to figure that out, right? But it's negative x, don't forget that. So then it's 21, 16 comes over subtracting, 11 comes over subtracting, the negative x stays on the right side of the equal sign. Okay, that's why it stays like that. 21 minus 11 is 10, minus 16 is negative 6. Right, so you divide both by negative 1, so x is equal to 6. Okay, 6 people like both authors. Okay, so that is your key. Remember, I told you that's your key to success. That is 6 that you found there. Then you go 16 minus 6, right? The 16 is the whole set. Take away the intersection. That's 10. On this side is 11 minus 6, which is what they're asking you for. That's 5. Okay. Now let's add this up. 10 and 6 is 16 plus 5 is 21 plus 4 is 25. So now when you add every section in this Venn diagram, you are adding up to the universal, which is what you want. Okay. Now you can answer. 10 people only like Sherlock Holmes, right? 5 only like the other one. And I just call the other one the other one. Okay. And 6 like both if they had asked for it. The question wasn't asking for it. You are going to automatically go there. You're going to figure out this and then work your way out to fill in the rest of the Venn diagram. Okay. Now, you have to put your thinking caps on. Okay. You will sometimes be asked how many people liked none of them, right? Like the outliers. So they'll have to give you enough information to figure that out. Okay. But always remember, use pi to get you started and fill in the center if it's not given. Okay? Okay, now, stop talking. I want you, okay, to go to page 16 and also try page 17. Okay? So no AC today, but you're going to try pages 16 and 17, and then I will kind of correct it, even though you're not going to rip it out and give it to me, right? We're going to correct it and see if I gave you an AC tomorrow, and obviously this isn't going to cover everything, but are you prepared for an AC, right? And then I will also announce the test date, and I will also give you a quiz date, because on this unit we're going to write a quiz as well, okay? So I'll pause the video here, and then we'll continue in a bit, and then we'll I'm going to start on page 16, and once we get to 17, then I will actually talk. So I'm just going to make some observations here and there. I don't know if you noticed me do that just now. I eliminated the ones that are in here right away, and then I eliminated these two from my universal, and then I'm left with my outliers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it matches. I also want to make note of this. Elements that are in F or Z, so that's a union. So then I actually want you to tell me using you can put this in brackets or just leave it like that, it's up to you. What's in the union, right? So it would be all of, like, if you combine both circles, it would be all of that, and it has to be in alphabetical, right? Oh, so B, C, H, I, and J. So if that helps you, would just write them all down and then arrange if you'd like. So this is proper notation. Elements in Z and F. So this would be Z and F, and not the number of elements, but the actual elements. So that'd be BHI. Okay, so you can correct elements that are only, keyword only. Okay, if you ever see the only, you're gonna have to think of the backslash like that. Okay, so F, not Z. So that'd be C. And Z, not F. Only elements in Z would be J. So that's a single element in each one of them. Elements that are neither in F or Z. How would you write this using the notation? Do you remember that? Outliers. So this is how I want you to think of it: is F or Z, correct? Fuzz. What's the fuzz, right? It's all the fuzz about. Think of it as the elements that are not in either one of them. Does that make sense? Elements that are not in either one of them, or number of students or people that like neither one. That's proper notation. So it would be A, D, E, F, G. All right. So we never ask for number of. It's just state using proper notation the elements that are in there. Good. I hope you make corrections. Let's go over to 17, which is really before we start the 3-set notation. I want you to be quite comfortable with this. Okay, so you can be guaranteed an AC tomorrow on something like this. Okay, so Mr. Dirksen asks us grade 12 class of 35 students. That's important to me, right? What season they preferred most. 17 like summer only. 11 students liked winter and summer. 5 did not like either season. So this would be summer only, right? This is summer, not winter, correct? This is the number of students that like summer, not winter. I want you to identify the notation when you see words, okay? 11 students like winter, and that's the key word, and summer. So number of students that like winter and summer would be 11, okay? 5 did not like either season. What would that notation be? I just did it. Winter or summer, not, right? Would be 5. These are also called our outliers. The ones that would be in neither one of the sets, but would be part of the universal. But I don't have to say that, right? But the n of the the number of elements in the universal here is 35, right? And I tell you this already, I do Venn diagrams almost right away. If I notice it's set notation, I'm like, okay, whatever. And I know that there are students that like both. So there's an overlap. So universal is 35, summer, winter, summer only. Can I put, look up here, can I put 17 here? Summer only. Summer only. That 17 actually goes in here because of the word only. If it said like summer, put them up there. Yeah, right? So careful. Right? Summer. I don't want to write in here, but okay, but I will just for now. Okay, summer only 17. So I think I'm going to come up with a few what identify the mistake the student made, right? And then boom, you need to figure out what was done wrong here because that's often eye-opening as well. So the intersection between the two is 11. That goes right in here. This section right there is what we call, right, the intersection of the two. And that is there. What else do I know? I know that there are 5 students that like neither one, so that is those are your outliers. Can you now already fill in a bit more though? Francis is thumbs up. What's the thumbs up for? My lesson or just, oh, that, okay. What else can you fill in? Okay. 17, 11, 5, okay. And then from there, take 35 away from that. And then you get the amount like. He's doing pi. He's just not knowing. You don't realize it, right? But that's the whole idea of realizing. Oh, I need to add this, subtract that. If you can do it, if I don't tell you have to use pi, you just go for it. You have my full blessing for that. Just make sure you show me the work. Okay, show me work on the outside. So what I will do is this. I will do red with the stuff I added after. 17 and 11. That's 28, right? Can I just do this here? 28? Because these two combined gave me what the whole circle is. Good. And so I will use pi in here, guys, because I want you to see it. Or will I just go with Francis' method? Francis's method works. So, yeah. I know that the number of elements, if I combine S and W like this, if I combine them, it would have to be NS plus NW minus, oh, that's going to be tough to do. I'm going to call this, can I redo it? Sorry, guys. I need more space. Let's try it again. NS plus NW minus NS NW. Okay, so we've got that. This here is 35 minus 5, right? Because I got to take, if I want the union, I need to take away the outliers. NS is 28, NW, I don't know. This is my unknown. So I'm going to call that X. Does that make sense? We haven't called that X before, but this is my unknown. Minus, do I know this? Absolutely, it's 11. I know the intersection of the two. So then we're left with 30 is equal to 28. One more line, okay? It doesn't hurt. So you're left with this. Now I'm going to bring all the numbers over to the other side. So I'm going to go 30 minus 28. What happens to this negative 11 when it crosses the equal sign? It turns positive. And on the other side, I'm left with X. Okay. If you were able to get this without doing it this way, I'm okay with that. I'm okay as long as you show me the work. So then it's 30 minus 28 is 2, plus 11 is 13. there are no negatives here, so no need to do that. So the number of students that like winter would be 13. Okay? So now watch this. This 13, I will just follow and put it up here because that's what you just found. And then I can figure this out. 13 minus 11. How many students like winter only? 2. Not many. Okay. Those are probably students that have a snowmobile or something like that, right? They like winter sports, or you just like winter. Nothing wrong with that. So now that you fill this in, I answer. A, determine the number of students that like winter only. Right here. Only 2 students. And I'm going to set it up in such a way that you will have to show me some work to score marks for this part, because obviously we had to do a significant amount of work. Can I just put here, we use pi, okay? Try to make it as catchy as possible. That's all I came up with, right? Use pi for that. B, determine the number of students that like either winter or summer. Not a really big deal. Winter or summer, or what does that stand for? Union, right? Right? Or stands for union. So that would be 17 plus 11 plus 2. Right? So the union is when you combine both circles, that is 19 and that's 30. Obviously, we knew that it was 30. I'm just making it. And you're like, well, don't we have to subtract, Mr. Dirksen? No, not it, because we're adding these sections individually. Then you can just go ahead and add. Once your diagram is filled in, you can just add the sections and you come up with the right answer. So 30 students like either one. Either season. That would be, what we just found is S union W. Okay, draw a Venn diagram and explain what each section represents. How about we do it right on there? Summer, like summer only, and then winter only. Normally, I wouldn't want you to write in there, but I already started it. So. And then N of S and W, okay, that is 11, like both seasons. N of S, not W, right, is 17, like summer only. And then the other one, N, W, not S, 2, like winter only. That's why I left so much room there for that. So you, in a sense, on a Venn diagram, when it's only 2 sets, you have 3 sections on inside those sets. 3 sections. Only, both, only, right? Only, both, only. Okay. All right. What are we at? Okay. I can start the next section here. I'm going to stop this part here. If you want more review, guys, on 2 sets, watch down here. Some of you, those on page 172 you already worked on, but 178 is also textbook review. Okay, so these are both from the textbook. So if you want more on that, you go ahead, right? Okay, let's keep going. I will stop this recording.